So we are graphing an intercept form today. So here's what intercept form looks like, and it may be familiar to you, I don't know. I got messed up there, that's an X, because I thought I heard someone swear.
You always did.
I would not.
Because
Ryan did.
One time you looked at me and are you kidding me? And I was like, I said car. And you were like, oh.
What?
You know, like, she got so mad
Ryan
at me.
did just swear, so.
Come on.
So here's intercept form. A equals, and then we have two binomials, x minus p times x minus q.
It looks exactly like if you divided a trinomial, and then you tried to find the factors.
That's exactly what it is. It's like taking a quadratic and just factoring it. So if you already have your quadratic in factored form, you can graph it in intercept form. Because think about it, when you factor a quadratic and then you solve it, those two numbers there, aren't they just where the thing is crossing the x-axis? Isn't that the whole point of solving a quadratic? Right? Yes. So if you're here, you already basically know where it's crossing the x-axis, and it's at these two locations, P and Q. So they're just numbers. So P and Q are your x-intercepts, and A is still everything that it's always been. A is still going to tell us up or down, wide, narrow, okay? So A is still wide, narrow, up, down.
Miss Xavier,
Yeah.
why does it have to be x minus p and x minus q? Why do they have to be such specific variables?
So that's a great question. I don't know why they chose P and Q. I really don't. But, yeah, I'm not sure. So P and Q are just your x-intercepts. So this time, so in vertex form, you got the vertex for free. You didn't have to do any math. This time, you get the x-intercepts for free. You can just look at it and you know what they are. You don't necessarily know what the vertex is, but that's okay. So, let's try one. So say I gave you y equals 2 times x plus 1 times x minus 3. So, if I'm just looking at this thing, this and this, if I'd solve this quadratic, if you will, I would get my two answers of where this thing is crossing the x-axis. So, it's going to be at, what two numbers? Be careful. -1 and +3, right? So, the x-intercepts are -1, +3. So if I'm going to graph, I would actually start right there. I'd put a dot at each of those. In fact, I will. Do you guys want to use this again today?
Yes,
You can. Someone wants to start it and then just pass it around. So fun. Okay, so if I'm going to do this, my x-intercepts are at -1 and 3. So I'm just going to put those dots, -1 on the x-axis. It's crossing there, and it's crossing out +3. 1, 2, 3. The other thing I don't love about this, I kind of wish it didn't have the little half marks.
So annoying.
It is, to me. So actually, I'll label them -1, -2, -3, 1, 2, 3, 4. Okay. So I have my two x-intercepts. I don't necessarily know exactly where the vertex is, but I kind of know something about the vertex. Doesn't it have to be exactly halfway in between those two? Right? So what is exactly halfway in between -1 and 3?
So 1.5.
1/2.
1/2.
1. There's an easy way to find out. You just add the two numbers together and take half of that. So negative 1 plus 3 is 2. Divided by 2 is 1. So 1, check this out. This is so handy. I'm going to draw my axis of symmetry. Right there. Because I know it's there. I don't know where the vertex is on that line, but I know it's somewhere on that line. Does everybody agree? Right? It's got to be on that line. So I know the x-coordinate of the vertex. The x-coordinate has to be 1. 1 comma what, though? How do you think I find that? Exactly. So, to find the vertex,
Who else needs this?
everybody over there.
Can they catch?
No, could you kindly walk it over? To find vertex, the x-coordinate is, you can just add P and Q together and divide it by 2. Or halfway in between P and Q, your two x-intercepts. However you want to think about it, doesn't really matter. But that's what you're doing, okay? So in fact, I'll even say halfway between x-intercepts. So that's the x-coordinate of your vertex. So we already know ours is at positive 1. So now I'm just going to take positive 1 and plug it back into my equation and see what comes out for y. So then plug that number into equation for x to get the y coordinate. So in this case, let's see. Now, this sometimes throws kids off. If I look at my original, there's 2 x's. Which one do I replace with 1?
Both.
Both! X is 1, so both of those x's get replaced with 1s. And then I just do my math. So I'm going to do 2 times 1 plus 1, and then 1 minus 3. Just like that. And then I just do the math. So that's 2 times 2 times negative 2. So negative 8. So now I know my vertex is at 1 comma negative 8. Oh, which is way off my grid, but whatever. So 1 negative 8 would be way down. Well, that's 1, 2, 3, 4. So I have to go that much more back down. Out there.
So that's your vertex.
Yep, right down there. I make this axis of symmetry a little bit longer. Yep. Go so fast. So, what's nice about this is I pretty much don't need any other points. I already have the vertex and my axis of symmetry, or vertex and my 2 x-intercepts. So the only time that I would plug in more points is if I had something like this. Let's say you got, let's say your 2 x-intercepts were like right near each other and the vertex was like right here. Well, that's not really enough for me to make a nice, accurate looking graph. So I might plug in, find the y-intercept maybe, or some other value, because that's just not enough. Okay, but this one was nicely spaced out. I mean, I would encourage you to plug in another point. You're going to have to find the y-intercept anyway. Oh, let's do that. So if I want to find the y-intercept, I would expect it to be some negative number down here. So if that's 0 and that's negative 8, some negative number between 0 and 8, negative 8. So let's see what we get. How do I find the y-intercept? plug 0 in for x. So that would be 1, that would be negative 3. 1 times negative 3 is negative 3, times 2 is negative 6. And that is a reasonable number. 0, negative 6 looks very reasonable for where my graph would cross the y-axis. Okay, I'm going to give you a worksheet. And we will try, huh? Can we do them on the board? Maybe, I don't know. So, I found this one on the internet. I haven't done it yet. So we'll see how good they're. We'll see if they gave graphs that are actually fit on the grid or not.
You too, Ryan. You too.
You have those. Do you have your phone?
Nope.
No way. The assistant. Miss Sylvia?
Yes. Here's one for Ryan. Okay, let's take a look at the first one. So, I know that this thing must cross the x-axis where? Positive 4 and positive 10. So I'm going to start by putting dots at positive 4 and positive 10. Where is my, what's the x-coordinate of my vertex? 7. If you add them together, right, positive 4 plus positive 10 is 14, divided by 2 is 7. So at 7, that's where my axis of symmetry is going to lie. My vertex will be somewhere on that line. I just don't know where. It's going to be 7 comma something. Did I lose you?
No, I just thought that the vertex was positive 4 and 10, so that's where I
Oh, no. Yeah. Those numbers are the x-intercepts, positive 4 and positive 10. Two separate ones, yep. This one you have to do a little bit of work to get the vertex. You don't get it for free. So how will I figure out what the vertex is? It's at 7 comma something. So what do I do?
Wait, how do you know it's 7?
Because it's halfway in between those two. I'm going to take 7 and I'm going to
Plug it into the
plug it right back in. So I plug in 7 for x and see what comes out. So 7 minus 4 is 3 times 7 minus 10 is negative 3. So I get negative 9. Did you? So now I know my vertex is at 7, negative 9. And now looks pretty good. I can kind of connect these dots. I could actually follow our pattern too. What's A? 1. So I should be going up 1. This line didn't quite print, but you could imagine that there's 1 right there. I would go up 1, then I would go up 3. And then if I go up 5, 1, 2, 3, 4, 5. Well, what do you know? It's already there. Isn't that great? And then connect with a nice smooth curve. Ta-da! I agree. I think standard form is the worst because you really don't get anything for free in standard form. You have to work to find the vertex. You have to work to find the x-intercepts. You kind of get the y-intercept is sort of free. Big whoop. Let's jump down to maybe 3. So go ahead and plot your 2 x-intercepts and find your vertex. You try that, and then we'll go from there together. Okay, what are my x-intercepts?
3 negative.
Are you guys all doing 3?
Oh, I thought you said 2.
Oh, sorry. Yeah, if you're going to do 3, you would have it at -2 and +4, right? Be careful, because it's as if you're solving these quadratics. So -2, we'll put a dot. 1, 2, and then +4. So what is halfway in between -2 and +4?
0. No. 2.
2.
1.
Oh dear. Okay.
6 and a
Wait,
half.
hold on. No, 1. It's 1.
1. Well, you got to add -2 plus 4. So that gets you 2. 2 divided by 2 is 1. So, and, I mean, if you draw in that axis of symmetry, it should be, you know, exactly halfway in between those two. Right. If it's not centered, you've done something wrong. You could literally just count boxes. Now, sometimes it doesn't always land at a nice point, right? The halfway point could be like 2.5. Okay, sometimes that happens. So, I know my vertex will be at 1 comma whatever. Take 1, plug it back in, and let's all make sure that we get the same answer.
Would you distribute the negative first?
You can, but I probably wouldn't. So if I'm going to do it, I would just plug in 1. So that's 3 times 1 minus 4 is -3. And then I would just times the whole thing by -1. So I would get that. Did you get that?
Because you multiply them?
So you're taking 1 and you're plugging it in, right? So 1 plus 2 is 3. 1 minus 4 is -3. So 3 times -3 is -9, but there's this negative out in front, so it's going to be a +9. So now I have my vertex at 1, 9. And if I connected those dots right now, it is down like a frown, like I thought it should be. If you want to do the pattern and see if it lines up, it should, right?
Wait, how's it 9? If it's -1 times 3, -3,
Times another -3
would be negative, would be 3.
would be +9.
No, but -1 times -3 is 3.
-1 times +3 is -3.
Yeah.
-3 times -3,
But wouldn't you distribute the -1 to the -3? Too?
what?
Why would you just do it to the first one?
No, she's not distributing.
I'm not. So if you do distribute, you can, but it'd be -x minus 2, and then times an x minus
So
4.
you just do it by the first one, to the first
Yeah, like if you do 2 times 3 times 5, don't you do 2 times 3 to get 6 times 5 is 30?
I know that. What?
You, right? If, multiply those three numbers together. What do you get when you multiply 2 times 3 times 5? Christina, what do you get when you multiply 2 times 3 times 5? 30, right? You don't do 2 times 3 and 2 times 5, right? Because then you get something, that's not what that means. So you're just multiplying 3 numbers together right down the line. -1 times 3 times -3. 9.
Yeah.
So, yes, you can check the pattern if you want.
I'm never asking questions.
A is, you keep right on asking. You don't even listen to what anybody else says.
Ask me for asking a question.
Well,
Yeah, Caleb goes, are you dumb? You don't distribute it.
Caleb.
wow. Who's going to get it right on the test? That's all you got to worry about. Because you're asking, that wasn't a slight against you, Caleb. I'm just saying, you got to, if you're stuck on something, you got to ask. Anyway, down 1 over 1. Then we go down 3. 1, 2, 3 over 1. Mirrored over. And then the next one, down 5. It's already there. Oh, happy day. Connect with a nice smooth curve. It's everything we ever thought it would be. Yeah, if you're going to follow the pattern, down 1, down 3, down 5. Why, what? That's just the pattern. It's always by the odds. So if A is 1 It's 1, 3, 5, 7, if you kept going. No. It's, oh yeah, well if it's 2, then you do 2 times all those numbers. If it's 3, you do 3 times all those numbers. If it's 10, you do 10 times all those numbers. So yeah, so you always start with 1, 3, 5. And then just multiply by whatever A is. Alright guys, if you flip to the back, I'd like to do one of the ones with the fraction as A. They're all a half, so that's not so bad. 8, sure. Okay, let's look at 8. So, again, I'd like you to start by finding your vertex. Plot the two x-intercepts, figure out where that vertex is. Sure.
So I was looking at 2, and it ended up like when I plugged in, because the middle was at 0, and when I plugged it in, it was 0. So now what would you do?
It's not 0. If you plug 0 in for x, wouldn't you get -3 times 3? Yeah.
I was adding, okay.
Yeah. So 8. That's okay. Again, you'll never find the answer to your question if you don't ask. Exactly.
Yeah, unless Caleb just comes to your Brooklyn.
Ryan, Josh.
Is it a decimal?
No, it's a high. It's 3 above ground.
Oh.
Unless I did it
Let's see. I don't know where it is. I haven't done this sheet yet. All right, guys. Where are my x-intercepts?
8 and -4.
Positive 8, -4. So, positive 8, -4. So, if I add together positive 8 and -4, I get 4 divided by 2 is 2. So, that's where my axis of symmetry is. That's the x-coordinate of my vertex. It's going to be at 2 comma something, right? Did everybody get 2 comma something? We're in agreement there? Okay. So, let's just go ahead and plug 2 into our original equation and see what comes out. So, 2 minus 8 is a -6. 2 plus 4 is a +6. That's -36 times a half. I get -18. So, you're right, that is a little bit off my graph, but it's not so far. So, I can just approximate 2 -18 would be right about 16, 17, 18. Right about there. I do wish it went a little bit further just so we could do the pattern. I mean, we kind of can. We just have to be careful. The pattern now is not up 1/2. That is not what you would do. You would take 1, 3, 5 and multiply them all by a half. So 1 times a half is a half. So you would go up a half a box over 1. Then instead of going up 3, you'd go up 1 1/2. So a half 1 over 1 more. What? So on your last quiz, you didn't have to graph it? Maybe. And then I would do 5 times a half, so up 2 1/2. 1, 2 1/2. Oh wait, 1, 2 1/2 over 1. And mirror that over.
I don't like doing the pattern.
Yeah, you don't have to do the pattern. But as you can see, it's kind of lining up very nicely. So when I go to connect all this,
So wait, for number for number 4, would you move 2 boxes instead of 1? Like
Yes.
2 or something?
yes. So instead of going 1, 3, 5, you go 2, 6, 10. If you were gonna go that far.
Ryan, I'm
Ryan?
gonna kill you. Okay, wait, so for 8, you went a half and then
You go up so instead of doing, so it's normally 1, 3, 5, right? You take all of those numbers and you always multiply it by whatever A is. So times a half, times a half, times a half. So the next dot after the vertex, you go up half a box over 1. This next one, you go up 1.5 boxes over 1. This next one, you go up 2.5 boxes over 1. Or you could ignore the pattern altogether and just plug in values for x and see what comes out. Sure. So, if we are checking out number 4, we're going to start with our x-intercepts, which are at 3 and negative 5. 1, 2, 3. So, if I add 3 and negative 5 together, that's negative 2. Divided by 2 is negative 1. So, my vertex will be at negative 1, comma, something. So, all I have to do is the math that goes with that. So, let's see. I'll do 2 times negative 1 minus 3 is negative 4. And negative 1 plus 5 is positive 4. So that's negative 32?
Yeah. I thought I was just like really off the graph.
Oh,
I was wrong.
yeah. Oh, this one is quite off the graph.
Never mind, I guess I was. Do we have to like graph it if it's like.
I mean, you would just, here's honestly what I would do for this one is I would just go like way down here, like it'd be somewhere down here, and then I would just make my graph. There's my graph to the best of my ability. So I guess they didn't do a good job of keeping everything on the scale either.
Wait, how did you get negative 1?
Halfway in between negative 5 and positive 3.
No, I'm talking about before.
How did I get negative 1?
Yeah, like, no, like, can you go to the equation? How did you get?
Because.
It's not from there. It's from halfway in between negative 5 and positive 3.
Number 5 is wouldn't it be?
Right? Negative 5, positive 3. Add them together, you get negative 2, and divide that in half. So negative 1.
Number 5 is also like,
Is this super off?
not very off.
Thanks a lot, kidsmarteducation.com. You are not my personal link to success. All right, but you guys get the idea? You want to try some on the board?
Yes.
All right.